the $150 billion International Space Station. Humans have always loved to explore and carry out various projects to reach discovery. They built various laboratories and designed and invested in various machines, aircraft, and accessories. Planet Earth has been explored almost entirely, and the living being on it is as well. However, the universe has always been tempting but unattainable for many centuries. With the advancement of science and technology, people will manage to travel there, even landing on the moon and other planets. What was once imaginable is now normal. Astronauts who went into space and investigated various phenomena had to stay somewhere, right? That's why space stations were built, and the effort was made to make them more modern and better. So in 1998, representatives of 15 countries met in Washington, D.C. and agreed to an unprecedented partnership for the design, development, operation, and use of a space research station. Today, 16 years and more than $150 billion later, the International Space Station, ISS, is the largest, most expensive laboratory ever built in space. The station originally was scheduled to be shut down in 2016, but it has now been funded through 2020, and it may operate until 2028. Because of its continued funding, repairs are being made to extend the life of the station. The ISS is continuing to conduct valuable microgravity experiments and to expand research into other areas, including biology, physics, astronomy, and meteorology. In addition, the Russian Space Agency is doing work aboard the ISS to assemble its next space station to be called OPSEC. To continue the video, there is a one-click rule. All you have to do is click subscribe, and that way you help us a lot and truly appreciate it. Now we can hear and see a lot more about the ISS. International Space Station is the largest modular space station currently in low Earth orbit. It is a multinational collaborative project involving 5 participating space agencies: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA, Canada. The station serves as a microgravity and space environment research laboratory in which scientific research is conducted in astrobiology, astronomy, meteorology, physics, and other fields. The ISS is suited for testing the spacecraft systems and equipment required for possible future long-duration missions to the Moon and Mars. The station is divided into 2 sections. The Russian Orbital Segment, ROS, is operated by Russia, while the United States Orbital Segment, USOS, is run by the United States as well as by other states. The Russian segment includes 6 modules. The US segment includes 10 modules whose support services are distributed 76.6% for NASA, 12.8% for JAXA, 8.3% for ESA, and 2.3% for CSA. The space station is the size of a football field, hovers from about 250 miles up, and has posted more than 225 people since 1998. It was envisioned as a laboratory, though also as a possible pit stop for missions to the Moon or Mars. What is interesting is that the ISS is a modular space station. Modular stations can allow modules to be added or removed from an existing structure, allowing for greater flexibility. There are a couple of major station components, areas with pressurized sections accessible by the crew without using spacesuits, but there is also an unpressurized superstructure in the station. Besides these areas, there are non-installed temporary defunct or non-commissioned components. Of course, the station is equipped with various systems that keep people inside alive, and some of them are the atmosphere control system, the water supply system, the food supply facilities, the sanitation and hygiene equipment, and fire detection and suppression equipment. Yes, the space station is well equipped, but you are wondering how all those systems and parts are powered. Up in space, there are no power cables that we will connect to make the station work. Double-sided solar arrays provide electrical power to the ISS. These bifacial cells collect direct sunlight in one side and light reflected off the Earth on the other, and are more efficient and operate at a lower temperature than single-sided cells commonly used on Earth. A pretty clever solution, right? During the construction of this space station, communication with the crew was also thought of. How did they do it? Very easy. Radio. Radio communications provide telemetry and scientific data links between the station and mission control centers. Radio links are also used during rendezvous and docking procedures and for audio and video communication between crew members, flight controllers, and family members. As a result, the ISS is equipped with internal and external communication systems used for different purposes. Maybe you didn't know, but this station is also equipped with computers. 100 IBM Lenovo ThinkPad, and HP ZBook 15 laptop computers. The laptops run Windows 95, Windows 2000, Windows XP, Windows 7, Windows 10, and Linux operating systems. Each computer is a commercial, off-the-shelf purchase, which is then modified for safety and operation, including updates to connectors, cooling, and power to accommodate the station's 28V DC power system and weightless environment. ISS crew members have access to the internet and thus the web. This was first established in 2010, allowing NASA astronaut TJ Creamer to make the first tweet from space. This is it. Hope you enjoy the video. Drop a like and share the video. Don't forget to leave us comments in the comments section below. Thanks for watching. See you